Today we're going to work on 3.2. Do you guys know what similarity means? Similar polygons? What are similar polygons? Oh, good. They're the same shape. They look kind of the same, but they're just different sizes. What do we call it when two polygons are exactly the same? Starts with a C. Congruent. So congruent means same in every way, except maybe orientation. So maybe it's been rotated or moved around or flipped or reflected, something like that. But to be similar means the shape is the same, but they could be different sizes. So anytime you have two polygons that are similar, the sides are proportional. And here's what that means, except that's really weird. I don't see. Whoa. Hey, there's our movie. Oh, I don't know that I brought it over. Oh, I didn't. There it is. So, these two triangles are similar. They're the same basic shape, just one is larger than the other. So all of the side lengths on similar polygons are proportional. The angles are all identical, but the side lengths are proportional, which means that if we find corresponding sides, so the long side, oops. So here is the long side. Man, I'm not. How about third time's the charm? There we go. That is the long side, and that is the long side. We say that those two sides correspond to each other, and they're also proportional. If we find the middle side, so this one, it corresponds to this one. And then the short side corresponds to the short side. Okay? What does it mean to be proportional? Do you guys know? No? So proportional means they have the same ratio. So if we took 56, this one, and we divided it by the length of its corresponding side, 8, we get 7. Okay? What that means is the big polygon is 7 times larger than the small polygon. All right, so I need to get rid of this thing. There we go. So if we check the other side, 28 divided by 4 is also 7. Okay, so we also have the question mark side. How big is it going to be? 49. So 7 times our scale factor, which is 7, is 49. Oh, look at that. The bottom is not the longest side. I was wrong. So this is going to be 49. Okay, let's do another one of those. I need to make sure that this is it? Okay, it's working. We'll do another one. Okay, what is the scale factor here? So this side corresponds to that side. So what's the scale factor? Well, they're similar, which means they're the same shape. One side is bigger than the other. How many times bigger is the large one compared to the small one? 6. You see that? 30 divided by 5 is 6. Okay, is that true of the other side? Yes, it is. It's actually going to be true of all sides. Okay, so how are we going to find this? Why are you dividing? Yeah, so in the last problem, we took the small triangle and we calculated the side of the large triangle. But this time, we know the large triangle, we need to calculate the side of the small triangle. So 24 divided by 6 is 4. Okay. Now the scale factor works in both directions. Okay. So if we're talking about the scale factor from here to here, then that scale factor is 6. What if we were going in the other direction though? What is that scale factor? Well, it's sort of the opposite of 6, which would be 1 over 6. Right? From small to big, the scale factor is 6. From big to small, the scale factor is 1/6. All right. So the same is true of quadrilaterals. So it tells us that those two quadrilaterals are similar. Find the length of SP. So we want this length here, and we just check what is the scale factor. The small one is 2.5, and the large one is 5. They're timesing by 2. And it's probably a good idea to check another one. 1.5 to 3, that would be multiplied by 2. This one, 1 to 2, that would be multiplied by 2. So if I know that the long side is 7, x is going to be 3.5. Okay. Are these similar? Which means the same shape. Okay. So here's how we can do this. We could rotate it. It looks like I'm going to have to go to my computer to do this. So we need to see if we can move this triangle and create this one. So I'm going to flip it. I'm going to move it. And I need to change its size. Come on. Are they similar? Really close, but not quite right, so not possible. All right, so here, I'm going to rotate this, and I'm going to reflect it, and then rotate it, and then move it, and change its size. Oh, got it. Okay. So this is called a reflection. This is called a rotation. This is called a translation. And then this is called a dilation. So reflection is a mirror. Rotation makes it spin. Translation moves it left or right and up or down. And then dilation changes its size. Oh, we just did that one. Okay. So here it says angle E is 15, angle F is 95. What are the angles of this triangle? Okay. So I'm going to find the long side. So this corresponds to this. And this corresponds to this, which means this corresponds to that. So if we look, the angle that touches the 1 and the 3 over here will also touch the 1 and the 3. So this angle is 15, which means this angle is 95, and then you just subtract them from 180 to figure out that last angle. Okay. And the last problem. So, can we translate that to equal this? Well, we need to check the side lengths. So 1, 2, 3, 4, 5, 6. 1, 2, 3. Okay. This one is a 2, and this one is a 1. This one is a 4, and this one is a 2. So are those similar? Yes. The scale factor is multiplied by 2. So which one of these will move this to there? So this is figure A. If we go up 4 units and then dilate that with a scale factor of 2, so if we go up 4 and then make it twice as big, will it match up with this one? No. Reflect A over the y-axis, so we would flip it from here to here. I'm going to have to draw that because that's going to be a little bit confusing. So if we flip it across this, then it's going to look like that. So flip over the y-axis and then dilate that with a scale factor of 2 centered at the origin. So what it means is we're going to stretch it from here in this direction. So it would end up being twice as far away, something like this. So that's not going to work. Rotate counterclockwise 90 degrees and then dilate that result with a scale factor 2 centered at the origin. So if we spin this 90 degrees, so it would look, that would be my center. It would look something like this. And then we would flip it. And that's not going to work. Okay, so dilate with a scale factor of 2 and then rotate clockwise 180 degrees. So it's going to move twice as far here. And then it's going to spin it 180 degrees. That's the one. All right. Okay. Get to work.